Hey everyone, thank you for having me today. It's nice to be here, and I love the city and the vibe on the conference, so thank you for inviting me. Today, I won't be speaking about what I do at JetBrains or the tools I use and so on. Instead, I decided to present you a fun side project that I have, which is automating my own home using a Raspberry Pi and Go. And I want to share my experience with you and make you understand the process behind it, and hopefully give you some thinking about, maybe how to start your next project working with Go, or if you're just started to learn Go, some of the cool things that you can do that are not web servers, web frameworks, databases, and all other generic stuff that I see doing. So. You can find me on Twitter at this handle, and I'll give you my handles in a bit as well. So first of all, what's a Raspberry Pi? Raise your hand if you know what the Raspberry Pi is. Oh, okay. So I was actually prepared with like a whole thing of like it has a CPU, it has some memory, and yeah, but it seems I don't need to explain what's a Raspberry Pi then. But basically, it's a tiny computer, right? To cut it short. In the latest iteration that was just announced like last week or so, you can see the board that now has 2 connectors for HDMI, so you can actually use it as a desktop replacement. And it has up to 4 gigabytes of memory, so plenty of memory to go around and play with it. It also has a smaller variant, which is called the Raspberry Pi Zero, and this is the W model, which is also the one that includes wireless connectivity. So this board, which is probably this bigger, like this big, and costs about $10, has a processor of about 1 gigahertz, 1 gigabyte of RAM, I think, if I remember correctly, wireless connectivity, Bluetooth, and so on, and even HDMI output. So you can get started and do some really interesting stuff with it. Today, I won't be using this one. I'll be using the bigger model, this one, which is called the Raspberry Pi 3. So yeah, since I had one of these at home, I was like, OK, what's next? Can I do something? So I was like, well, I know Go, but like, why would I choose it? As you know, probably, Go supports multiple platforms, and it can also run on ARM-based platforms, which is what Raspberry Pi uses as a CPU architecture. So, well, I'm using Windows on my machine. Some of you use Mac, some of you use Linux, right? So this is not a different story because all your CPUs are likely to be either Intel or AMD. Raspberry Pi has an ARM-based CPU. So yeah, it still works. It's the same Go code. It cross-compiles to a different platform. OK, cool. It's fast, even on these tiny computers where you think, oh, I don't have the resources. I'm running a garbage-collected language. It's probably not going to work. It actually works pretty well. And given that, at least in the current application, you don't need to do too many things at once. So there's not like, I don't know, handling billions of requests per second or something like that. The Raspberry Pi power is enough for what we need. It's also not C or Python, which I know like nothing about them except for the very basic stuff. So for me, starting to work on automating my home with C or Python would have taken probably a few good years because I needed to start and learn the languages themselves first. So yeah, well, those are the main languages that you get usually as an introduction or tutorial for developing on Raspberry Pi. And I'm like, no, never. So also, it gave me a chance to actually play a bit with the platform itself. It gave me a bit of chance to see what's the Go ecosystem like. Have we reached the level where, you can go on the internet, fetch some libraries, put them together, and get your stuff working in a totally random domain, like I said, not the classical one of web frameworks or databases. So turns out you can. It actually works. So I should give you the Pi now, right? And like start doing some demo and stuff because I've been talking for like 5 minutes already, but not so fast. The little box that you see here, and sorry if you're sitting behind, there's a little box here. It's actually where the Raspberry Pi is right now. It comes from a hardware project from Google, and you have the link there. And this is their website, if I remembered to open it. So you can go to this website. Let me make it up. We don't have. You can also get a vision kit, as they call it, which basically gives you a board that allows you to connect your camera from the Raspberry Pi and do some computer vision stuff. And there are projects for that as well, even in Go. And if you use machine learning, as we've seen in the previous talks, you can actually use a Raspberry Pi to run your TensorFlow models on that and have maybe connected to the camera and do some automation using that. But I'm not going to show that today because I'm way off from the machine learning part. I'm just into the voice stuff for now. OK, so let's quickly jump back here. So we were here. Right. So now you can actually have the Raspberry Pi. And let's have a look at the code, because this is meant to be mostly a talk about code and how you can write your own, right? These are my contact details, as promised. So if you ever want to write to me or tweet to me or something, you get my contact details from there. I'm also active on the Gophers Slack, which, in case you don't know, it's a community dedicated especially for Gophers, started by Bill Kennedy way back in 2014, I think, if I remember correctly. Something like that. So yeah, there's a bunch of people out there. There's like 40,000 people and growing. And you get to have a lot of channels and so on. And one of them is the IDE channel. Anyway, so let's start with the main function, which is always the interesting one, right? So we have a few things that happen here, and is it big enough? Can you see it? OK, raise your hands if not. It's OK, cool. So we're doing a few things here. I'm using the log package from the standard library because it's a personal project, and that's good enough. And I'm planning to use context, better said. For now, it's just plumbed through the whole code just to be there, so I don't have to refactor it later on. And then we use a few channels to accept the user commands, as it's aptly named, right? And we also have a wait channel, which is supposed to help us wait to process all the commands when we shut down. So it tries to do like a nice and clean shutdown. Right. Then we use a library for doing the output, and we need to initialize it. And this library is called port audio. And actually what I have here, it's a wrapper over the C library itself. So it's not something purely written in Go. And it works very well so far. No problems here. So nothing spectacular. In the defer, as you'd expect, we do a bit of cleanup as well. And yeah, error handling is all going to be log fatal because for now it's good enough. If I have a problem, I should know about it and see how I can fix it, and then I can do proper error handling. I'm not advising you to always do that, but for now it works. And I get to see all the errors when they actually happen. And then one thing that I would like to have in my home is not a spy, which is why I actually built this one and not bought a third-party appliance. And I'm not going to name Amazon Alexa or Google, what's its name. So none of those in my home. And the reason is that you get to see all those crazy reports, right? Of like, oh, it turns out that someone is snooping on your voice because you have a voice-enabled device, right? If I built it, I know what it's in there, right? I know when it activates, when it deactivates, what it listens to it, and when. So we need a wake word. The wake word is there to help us wake up the device and start actually listening to the voice commands. Without it, basically, we would need to snoop our voice and listen continuously for anything that matches a command. And if I want to make it a bit more conversational, something like, I don't know, turn off the lights, maybe I can say that to someone in the room, or I can say it to the device. Maybe I mean to talk to the person in the room, not to the device all the time, right? So the wake word is there to actually wake up the device and start listening to my commands. And what we can do there is, well, we basically feed some data to our libraries. And I'm going to jump in a bit later into what Porcupine is and why the name and so on. For now, we know that we have a couple of keywords that we listen to. We listen to Bumblebee, which is the name of the device, and we listen to Terminator, which you'll see a bit later on. And then we just initialize the library itself, and that's it. Right, so let's go back to our code, right? We initialize here some GCP services, and I said I don't want to have something that listens continuously to my voice without me knowing. But you need to build up somehow the voice to text and the text to voice parts. Turns out you can't really do that in Go currently without using a platform, a third-party platform. In my case, I use the Google Cloud Platform because they offer a free tier for these kind of operations. So if you register to Google Cloud, you get to have some, I don't know, 1,000 minutes or so of voice to text that they can give you for free, so you don't have to pay anything. And I think it's about the same the other way around, which is enough for a device that's supposed to only respond to commands and maybe tell me a few things like the weather or something. There are other services besides Google. There's Amazon. You can do this with, I think, Yandex, if I remember correctly, has something like this. There's one in China as well, Baidu, or something like that. So there are plenty of providers out there. And then, yeah, we just initialize the services and go through them. The commands part is something that I wrote my own, and it's a module that holds the commands together, and we'll jump into that in a bit. We do the registration for intents, which basically it's another way of saying we register the commands that we have here. Let me dismiss this one. So here in the intents, we see some of the actions that we have available. Like I said, I want to turn off the lights, turn on the lights. Maybe I want to set the lights to a certain value. Or I want just to say some hello, right? So this is the way I thought it should work as a structure. And if you want to see, let's say, the definition quickly, it's basically this. It's a structure which holds a few slices together. Basically the command, the alternatives, and what actions to take when it listens to the command itself. In my case, actions are basically callbacks, as you probably noticed. They receive some input to know that they've been triggered, and they do their stuff, perhaps returning an error. So pretty much I covered everything. For now, I thought that it's better to send the text-to-speech service everywhere, because it makes it easy for the command to then go back and ask me things. So I can say, I don't know, let's say, turn the lights to, and then maybe the device will say to what, right? And then have a more conversational way of talking to the device. Right, and yeah, in the callbacks, you'd get what you'd expect. Either pass this as using the context, or just say something like invoke an action itself, which, let's say, it's going to be like just saying hello, right? So just reply back. And that's about it from this point of execution, right? We registered our intents. There are many more that I have, but you can see I have a comment here that says restore after demo, because some of them are private for now, and I'm not really ready to publish them out, which is why the repository is for now closed source. Should do a bit of cleanup before. Right, so let's go back to our execution point. We were here and said register my intents. In background, we launch a Go routine. So basically like any web server, but instead of being a web server, it's a processor, which listens for commands And then we have basically our, well, endless loop here, which is supposed to always listen for commands. Actually, first, listen for the wake word, right? Because we said wake first, then listen for command, and then do whatever you need to do, right? So we'll listen for that. We'll check if we have the special keyword, which is called terminator. So now you know why we registered that wake word. And that's something that helps me debug it. So if I want to close it nicely, that's the command that I want to give to the device. And I'm just going to say terminator. Unfortunately, it doesn't occur too often in the Romanian language that I need to do that. So we don't have that word. It's fine. And then we just have the speech-to-text service, which processes the command itself. It will basically do the following thing. It will start a new request for our engine, so for Google Cloud Platform. Here, it's going to send the request, go do the request itself, and then it's going to parse the request and convert it back to whatever we receive from there. So basically, Google will do the job for us, the hard part of converting our speech to text, and we'll do the easy part of taking that text and going back with it. If you want, we can go a bit deeper, but yeah, basically this is all Google Cloud Platform at this point. What else do we do here? Well, not much in this particular package. So let me show you a couple of other packages that we have running in the background. So let's go to the wake word. As I said, we have the initializing part. We also have the listening part. And this is where we just get to see and listen to what we say to the device. And as you probably expect, we do a few things. We initialize our engine, our text-to-speech engine once, and then we say, OK, we are in a for loop, and start listening to the microphone in the background. It does listen to that, but there's one particular aspect that I like about this library. It listens without connecting to the internet. So all the recognition that happens on the device itself. I know that there's no connection between what I'm saying right now and some random server, I don't know, somewhere, trying to figure out if I talk to it or not. OK, and let's say we go back here to our packages, and we have the speech-to-text is pretty much what you'd expect. Just sending a request, and that's it. The text-to-speech is a bit more fun because we actually get to transform what we talk and how we talk from the device forward. So we basically have a couple of functions that take care of taking the text, feeding it to a few libraries that you can find in Go, and then just playing back the output. So at this point, if you look at the actions themselves, as I said, there's not much to do. Like, you can either say something like speak, and this will take my text, transform it, or just, here I have the actual code. It's deleted for now because it contained the passwords. So it's just connecting to the Hue device from Philips, and just turns off the light, turns on the light, and so on. That's about it. Like, in terms of the structure for the commands, it's pretty straightforward. There's not much that you need to do, actually. You just need to think a bit, OK, so I receive a command, now what? Well, I'm going to iterate for all the commands, do the matching, and see what happens. And we have a convert to intent, which is where the magic happens. So where the matching itself will be done. For now, I use a simple logic. So you actually have to say turn off the lights or turn the lights off. It won't work with some fuzzy speech for now. Let's say it's not going to be smart enough to recognize, please turn off the lights or something like that. That can be solved with a regular expression, for example, or with an intent engine that knows how to recognize placeholders. When I open source this, maybe someone will contribute to it, or I'll find time to actually do it myself. But yeah, there's a bit of time before that. And to actually prove it works, let me see if I can synchronize this. So I'm going to synchronize this, which sits on my laptop right now, with the Raspberry Pi, right? And I think I do have some changes. OK, so it's mainly to take off the passwords and perhaps not turn on the lights at home. And I do a launch script, which basically it's not going to be anything fancy. It's going to say, go build, launch it, and then remove it afterwards for debugging purposes for now. You could make it start as a daemon when Raspberry Pi starts. So as you can see, it's compiled on device in my case, and I do so because I need some Linux libraries. I said I'm using CGO in one of the libraries. For now, there's no native Go implementation of those wrappers. Maybe in the future, but for now, it's good enough. And it says something like, OK, I'm listening for those special keywords like bumblebee, turn off the lights.
I could not.
Well, it could not understand. Oh, it could understand, but I cut it off a bit earlier. It says that basically there was an error setting the lights off, right? And that's because, well, I cut off the API. So it works, right? Bumblebee, say hello.
Hello, Minsk.
So it works, right? I'm not sure if you could hear it, but I invite you afterwards to actually hear it properly. I'm sorry. It's just a tiny speaker. It's not a proper system. But that's the point. Like with, I don't know, let's say a couple of hours of work, maybe 4 hours or so, and the libraries that we have currently in the Go ecosystem, you can build something like this. And if I can automate my lights, what's the next step? Well, I can automate basically anything I have in-house. Because the Raspberry Pi supports, for example, infrared communication, right? So maybe I can turn on and off devices that were never meant to be automated, like the old AC that I have.
I could not understand your request.
Terminator.
All.
Bye-bye. So I tried to say, I'll be back, but I got a bit, well, it seems it got a bit shy. Anyway. Yeah, so you can automate devices that were never meant to be automated, right? And in my case, I do this from home, but you can put it somewhere else, for example, in your car, or to watch for, I don't know, some specific actions that you do. I mentioned that I'm using some libraries as well. So let me go quickly through it and show them. These are the guys that provide the library, and it's for free. It's not open source as far as I know. And it's called Porcupine, so that's where the name comes from. And it's the wake word engine behind it. And it's working very, very well. It uses like 25 kilobytes of memory or something. So it's highly optimized. They have a few other products here, but I'm not going to spend money on them, and I'm not really sure I can get them either, because they seem to be more geared towards, let's say, bigger players in the market, like automating a whole bunch of things for heavy money. So I turned on to these two APIs, basically the text-to-speech and speech-to-text APIs from Google. And as I said, these are free, and you can use them. They work well so far. Let me see if I can resume this with my PowerPoint skills. Right, so that's why I don't do slides, because I never know how to. OK, so we finished. So yeah, I never know how to resume this. Anyway, you can find some links here, and I'll send the slides to the organizer afterwards. I think the organizers in Russia still wait for them, sorry. And yeah, those are the libraries that I've used. It's Go Audio, which is really helpful if you want to do anything related to audio and Go. It works on Linux, as far as I know, at least. There's the Port Audio wrapper that I mentioned, which actually lets me do all the talking to back to the human. And there's the Porcupine wrapper, which wraps the C library. And they work pretty well so far. Also, there are a few other useful links that you have here. So it's basically GoBot, which if you're interested in Raspberry Pi, you should definitely check it out. Mainly because it's the, let's say, the first framework, if I remember correctly, for IoT that appeared. And it supports a lot more than just the Raspberry Pi platform itself. There are support for others. There's a newer framework as well called Perif. Again, same mission as GoBot, but yeah, different implementation. PicoVoice are the guys that I've shown you the library for wake word detection, and the Google Cloud Platform in case you want to read more. And I guess that's it. If you have any questions, please let me know.
Thank you very much.